Here are the answers for the section 13-8 homework. We have several questions where we need to expand the binomial. To do that, we need to know coefficients, which can be given in Pascal's triangle. So we need Pascal's triangle. When you have a binomial and you raise to the 0 power, you're going to create the answer 1. When you have a binomial raised to the 1st power, it's going to create that same binomial. So coefficients will be 1 and 1. When there's a binomial being raised to the 2nd power, it's going to create a trinomial. The coefficients will be 1, 1, and then 1 plus 1 makes 2. A binomial raised to the 3rd power will have a 1 in the last term, and then when you add those together, that's 3, and adding those together, that's 3. When you have a binomial and you raise to the 4th power, you'll have 1 and 1. This is 4. Adding these is 4, and 3 plus 3 is 6. Do you see the pattern that I'm using as I generate Pascal's triangle? When we have a binomial raised to the 5th power, we'll have 1 and 1. 1 plus 4 makes 5. 4 plus 1 makes 5. 4 plus 6 is 10, and 6 plus 4 is 10. And then a binomial raised to the 6th power, we'll have a 1 and a 1, and then 6, 15, 20, 15, and 6. And then a binomial raised to the 7th power, it'll be 1 and 1. 1 plus 6 makes 7, 7. 6 plus 15 is 21, and 21. 15 plus 20 is 35, and 20 and 15 is 35. And so on going down. In problem number 1, we're going to use the coefficients from this row of Pascal's triangle. The 1, 6, 15, 20, 15, 6, 1. So our answer will be 1 times c to the 6th d to the 0 plus then a 6 times c to the 5th d to the 1 plus now a 15 c to the 4th d to the 2 plus now a 20 c to the 3 d to the 3 plus now 15 c to the 2 d to the 4 plus now 6 c to the 1 d to the 5th plus 1 c to the 0 d to the 6th. Notice that in all of my terms, I have used the coefficients from that row of Pascal's triangle, and that I've used the first term from the binomial and the second term from the binomial, and as I went across, my exponents on the first term decrease, while the exponents from the second term are increasing. The final step is to run back through and simplify this. So this makes c to the 6th plus 6 c to the 5th d plus 15 c to the 4th d squared plus 20 c cubed d cubed plus 15 c squared d to the 4th plus 6 c d to the 5th plus d to the 6th. Now number 3. This time the binomial that we're expanding goes to the 7th power, so we're going to use that final row from the Pascal's triangle that I had done earlier in this video. The coefficients are 1, 7, 21, 35, 35, 21, 7, and 1. The other thing is there's a minus sign in this, so our even numbered terms will be negative. We're going to alternate the signs. So this makes 1 m to the 7 t to the 0 minus 7 m to the 6 t to the 1 plus 21 m to the 5th t to the 2 minus 35 m to the 4th t to the 3rd plus 35 m to the 3rd t to the 4th minus 21 m to the 2 t to the 5th plus 7 m to the 1 t to the 6th minus 1 m to the 0 t to the 7. Notice how I've used all of the coefficients from the appropriate row of Pascal's triangle. I'm alternating the signs, negative, positive, negative, positive, and that my exponents are always adding up to 7, which was the exponent of my original binomial. Like 7 and 0 is 7, 6 and 1 is 7, 5 and 2 is 7, 4 and 3 is 7, and so on. The final step is to run back through it again and put it in simplest form. M to the 7 minus 7m to the 6t plus 21 m to the 5th t squared minus 35 m to the 4th t cubed plus 35 m cubed t to the 4th minus 21 m squared t to the 5th plus 7 m t to the 6th minus t to the 7th. Number 9, we're going to expand this one, which goes to the 4th power. So using the correct row from Pascal's triangle, our numbers are 1, 4, 6, 4, 1. We have 1 x to the 4th times 2 to the 0 plus 4 x to the 3rd times 2 to the 1 plus 6 x to the 2 times 2 to the 2 plus 4 x to the 1 times 2 to the 3 plus 1 x to the 0 times 2 to the 4th. Now run through and simplify. This is x to the 4th, and then 4 times 2 makes 8x cubed, and then 6 times 4 makes 24x squared. Now we have 4 times 8, that makes 32x. And then 1 times 16 makes 16. Number 11. This time our binomial goes to the 3rd power. From Pascal's triangle, the coefficients will be a 1, 3, 3, 1. So we have 1 times 3x to the 3rd power times 1 to the 0 power. Then minus, because of the minus sign here, we're going to alternate signs going across. 3 times 3x squared times 1 to the 1st power. Now plus 3 again. 3x to the 1 times 1 to the 2nd power plus, and then 1. 3x to the 0 times 1 to the 3rd. Now simplify. This makes 27x cubed minus, and then 3 squared is 9. 3 times 9 is 27, times 1 is 27 again, x squared, plus, now we have 3 times 3, which is 9, x, plus, and then over here, the 3x to the 0 power, that just makes a 1. 1 cubed is a 1, and 1 times 1 is 1. And now number 15. This time we're going to the 7th power. So we need the coefficients from Pascal's triangle. They will be 1, 7, 21, 35. And then it repeats that, but counting downwards. Okay, let's build our expansion. 1 times the x squared raised to the 7th power times the 2 to the 0 power. Now a minus sign, then 7. Now we have x squared to the 6th power times 2 to the 1st power. Now a plus sign, and the number is 21. We have x squared to the 5th power times 2 to the 2nd power. Now to a minus sign. Now 35. X squared to the fourth power times 2 to the third power. Now a plus sign and another 35. X squared to the third power and 2 to the fourth power. Now a minus sign and 21. X squared to the second power, 2 to the fifth power. Now a plus sign and 7. X squared to the first power, 2 to the sixth power. And finally a minus sign. X squared to the 0 power and 2 to the seventh power. Now we need to run back through and simplify that. So on this first piece here, that makes x to the 14th. Now this second piece, this makes 7 times 2 is 14, x to the 12th. Now this piece here, this makes plus, 2 squared is 4, 21 times 4 is 84, x to the 10th power. Now this piece here, this is minus, 2 to the third power is 8, 35 times 8 is 280, x to the 8th power. Now this piece, 2 to the fourth is 16, so 35 times 16. That makes 560, x to the 6th power. Now this piece right here, so we have minus, 2 to the fifth is 32, so 21 times 32. That makes 672, x to the 4th power. Now this piece here, 2 to the 6th is 64, so 7 times 64. And that makes 448, x to the 2nd power. And now the last term, we have a minus, and then 2 to the 7th power is 128. Now page 516. For question number 2, we're asked to find the sum of an infinite geometric series. So for the sum of an infinite series, the formula was S equals A divided by 1 minus R. Value of A is 6, 1 minus negative 1/3. This makes 6 divided by 1 plus 1/3, or 4/3. This can be figured out by going 6 times 3/4, which makes 18/4, which reduces to 9/2. For number 6, we're asked to find the sum of this infinite series. The value of A is 9, and looking from term to term, R equals 1/3. So we'll use the same formula. For A, fill in 9, and for R, fill in 1/3. So this makes 9 divided by 2/3, which is equal to 9 times 3 over 2, which is 27 over 2. Now number 14, write out the first 3 terms of the infinite series. So we have 3, but then the next 2 terms we don't know. We need to know what R is in order to figure those out. So let's use our formula. S equals A divided by 1 minus R. In place of S, fill in the 2 1/4. In place of A, fill in the 3. Now let's do some algebra to get R alone. So 2 1/4 is the same thing as 9/4, and we can multiply the 1 minus R to get the 3 alone on the right side. Then we can multiply by 4 on both sides. Now there's a 12. Now we can divide by 9. So 12 divided by 9 makes 12 over 9, which does reduce to 4/3. Next up, subtract 1 from both sides. So negative R is equal to 1/3. Therefore, R equals negative 1/3. We multiply by negative 1/3 to find the successive terms in the series. 3 times negative 1/3 is negative 1. Negative 1 times negative 1/3 is positive 1/3. Now number 22. What common fraction is this repeating decimal equal to? Let's write this out as a series. This is 0.2 plus 0.05 plus 0.005 plus 0.0005 plus then ... Now, ignoring the first term and starting here at this piece, this is an infinite geometric series where the value of a is 0.05, and from term to term, we can see that r is equal to 1/10. Let's sum up that part using the formula. So for a, put in 0.05, and for r, put in 1/10. So this is 0.05 divided by 0.9. And that makes 5/90, which reduces to 1/18. Now this piece here we haven't done anything with yet. What fraction is equal to 0.2? That's the fraction 1/5. So our original decimal 0.25 repeating is equal to 1/5 plus 1/18. Let's get common denominators and add this together. If we use a common denominator of 90, then this is equal to 18/90 plus 5/90. And that makes 23/90. Next, page 517. Rubber ball dropped 40 feet, rebounds on each bounce 2/5 of the distance from which it fell. How far will it travel before coming to rest? So this sketch models this. If the ball starts up here in the air and it falls 40 feet, when it bounces back up, it will only go 2/5 of the distance. 2/5 of 40 is 16. Then the ball will fall 16 and bounce up 2/5 of 16. Let's model those distances. First, the ball travels a distance of 40. It hits the ground and bounces up 2/5 of 40, which is 16. Then it will fall that same amount. Then the ball will bounce up only 2/5 of that distance. And then it will fall that same amount. And so on. This sequence can be simplified as 40 plus 2 times 2/5 of 40 plus 2/5 times 2/5 of 40 plus ... Inside the bracket, we have an infinite geometric series where the value of a is this first term, the 2/5 of 40, which remember is 16, and the r is 2/5. So let's use our sum formula on the bracket portion of this. S equals a divided by 1 minus r. So this is 16 divided by 1 minus 2/5. So this is 16 divided by 3/5, which is equal to 26 2/3. Well, that's the sum inside the bracket. So then our total sum is equal to 40 plus 2 times the 26 2/3. And that makes 93 1/3 feet. Next, number 3. A side of a square is 12 inches. The midpoints of the sides are joined to form an inscribed square, and the process is continued as shown in the diagram in the book. Find the sum of the perimeters of the square if the process is continued without end. Well, if one side of the largest square is 12, then its perimeter is 4 times 12, which is 48. So I wrote down that first perimeter. Now what's the perimeter of the next square, the one that's inscribed it, kind of at an angle? Its perimeter will be 4 times each side of that square. So using geometry, we can find that the side of that next square is 6 square root of 2. So 4 times 6 square root of 2, which is 24 square root of 2. Now inside of that, there's a smaller square, and its perimeter will be 4 times the side of that smaller square. And with geometry, we can find the side of that smaller square is 3 square root of 2 times square root of 2. Or now we can find the value of r by finding the ratio between two terms. If we take the second term and divide it by the first term, we see that that ratio is the square root of 2 over 2. If we take the third term and divide by the second term, the 24 is reduced and we're left with 1 over the square root of 2, which rationalizes to square root of 2 over 2. So that confirms that this is geometric and this is the value of r. We can find the sum with the formula, a divided by 1 minus r. So this is 48 divided by 1 minus the square root of 2 over 2. Use a calculator to find this result. It makes 163.8.